All right, today we are taking a look inside Frontier. This isn't just any computer, it's the most powerful supercomputer on the planet. We're going to break down how it actually works, what makes it tick, and then explore some of the mind-blowing problems it's already solving. Things like designing futuristic materials and even helping us get to Mars. So let's get into it.
Okay, so let's kick things off with a problem that sounds like it's straight out of science fiction. How do you design a material that's stronger than steel, but you have to do it at the atomic level? I mean, think about that. You're trying to build the next generation of airplanes, right? You need something super strong, but also incredibly light. The real trick, the almost impossible part, is getting it perfect down to the individual atoms.
So what you're looking at here is a simulation of carbon fiber. You've probably heard of it, right? It's that amazing stuff they use in everything from race cars to modern aircraft. It's already a game changer. But the scientists over at Oak Ridge National Laboratory had this nagging thought. What if we can make it even better, even stronger?
And here's the thing. The problem isn't the carbon fibers themselves. Those things are insanely strong. Nope. The weak link, the real Achilles heel, is the glue, the polymer that holds all those fibers together. That bond is where it fails. So the huge challenge becomes, how in the world do you reinforce a connection that's happening at a microscopic scale, way thinner than a single human hair? Well, the answer to a problem that big requires a tool that's just as massive. And that brings us to Frontier, a machine built specifically to tackle these kinds of impossibly complex problems.
Let's dig in.
So this is it. This is Frontier. It lives at the Oak Ridge Leadership Computing Facility, and it has a very important title. It is the world's very first exascale supercomputer. Now, what that means is that it is, officially, the most powerful computer on Earth that's dedicated to open science research that's meant to benefit all of us.
So its peak speed is, wait for it, 2 exaflops. That number is it's just staggering. It's one of those numbers that's so big, it's kind of hard to wrap your head around. So let's try to break down what an exaflop actually is.
Okay, get this. It means Frontier can perform over a quintillion calculations. That's a billion calculations every single second. Just try to imagine that. It's an absolutely absurd amount of processing power. And it's exactly that power that lets scientists attack problems on a scale that was just completely impossible before. So the big question is, how does any machine get to be that fast? Let's pop the hood, so to speak, and take a look at the anatomy of this thing.
And when I say machine, I mean, look at this. We're talking about a massive physical system. Frontier isn't just one box. It's a whole room filled with 74 of these huge cabinets, all linked together, each one stuffed with some of the most advanced hardware ever made. It's less like a computer and more like a factory for scientific discovery.
So the real secret sauce to Frontier's speed is what's called a hybrid architecture. Now, the best way to think about it is like a highly specialized team. Inside each of these cabinets are computing nodes, and each node has a CPU, that's like the project manager, the brain of the operation, figuring out the complex stuff and telling everyone what to do. But that CPU is paired with 4 heavy-duty GPUs. Now, you know GPUs from video games, right? They're amazing at graphics. Well, here, they're repurposed as mathematical beasts. They are the workhorses, just crunching thousands and thousands of calculations all at the same time. This idea, massive parallelism, where the CPU is the smart boss and the GPUs are the powerful muscle, that is the engine that drives a machine like Frontier.
But all that power is useless without this. I love this quote. A supercomputer is only as fast as the network connecting its parts. And it is so true. Think about it. You can have all the fastest processors in the world, but if they can't share data with each other instantly, the whole system just gets bogged down. It's like having a city full of Ferraris, but they're all stuck in traffic. The network, or the interconnect, is the traffic-free superhighway that lets them all run at full speed. And this chart really shows you what a massive leap forward Frontier's network is. This is the HPE Slingshot Interconnect. First, just look at the bandwidth, 400 gigabits per second. That's basically double the speed of the last generation. But here's the really killer spec, the switch radix. That just means how many connections each switch has. With 64 ports, it can link up way more processors directly. It's like having a highway with more on-ramps and off-ramps. The result? More data, moving way faster, with way fewer traffic jams. It's a huge deal.
Okay, so that's the how. We've looked under the hood. Now for the really cool part, let's see what this beast can actually do. This is where all that engineering turns into incredible science.
All right, remember that carbon fiber problem we started with? The one about strengthening the bond at the atomic level? Well, here's how they solved it. The researchers used Frontier to build a simulation with, get this, 5 million individual atoms. We're not talking about a rough sketch. This was a perfect atom-by-atom digital twin of the material. For the first time, they could literally watch how every single molecule interacted. And here is the incredible result. The simulation showed them exactly what they needed to do. By adding a special kind of nanofiber into the mix, they could perfect the way the material handles stress. And as you can see from this chart, the payoff was huge. They found a way to literally double the strength of the material. That's a game changer.
Okay, let's switch gears from the super small to the super big. Here's another massive challenge: getting humans safely to Mars. NASA has to figure out how to land a vehicle there. But there's a tiny problem. You can't really do a practice run. You can't just fly over to Mars for a full-scale dress rehearsal.
So what do? You turn to Frontier. It lets NASA run these incredible, first-of-their-kind simulations. They can build a perfect digital copy of the Martian atmosphere, which is totally different from Earth's. Then, they can simulate the entire landing sequence, testing how the lander flies at supersonic speeds and, critically, how its autonomous landing systems will behave. It's basically a perfect virtual test flight, giving them all the data they need to build a vehicle that can actually stick the landing for real.
And Frontier's range is just amazing. It's not just for tiny atoms or planetary landings, it can handle problems on a galactic scale. I mean, look at this. This is a simulation of 2 entire galaxies smashing into each other. That's a process that takes millions of years in reality, but they can model and study it right here on this one machine.
Really, the list of applications just goes on and on. We're talking astrophysics, like we just saw, material science, like the carbon fiber, aerospace engineering for Mars missions, but also Earth science, where they can build super high-res models to predict flooding, and even clean energy research, like developing new kinds of fusion reactors. Frontier is really a universal tool for science.
So when you take a step back, what does all of this really mean? What does having this kind of computational power actually do for the future?
I think this quote from Swarnava Ghosh, one of the scientists on that carbon fiber project, just nails it. He says, ultimately, we're trying to make materials not just stronger, but smarter and more efficient. And that's the key, right? This isn't just about building the fastest machine to have the fastest machine. It's about using that speed to create tangible things, smarter technologies, better products, more efficient systems that impact the real world.
At the end of the day, what a supercomputer like Frontier really does is it hits the fast-forward button on science itself. Think about it. Problems that would have taken years and years of slow, expensive, real-world experiments, all that trial and error, can now be solved with a simulation that runs in a matter of days. It's a total paradigm shift.
So this incredible technology gives us the power to solve problems that, just a few years ago, we would have considered completely impossible. And that leaves us with one final, fascinating question to think about. Now that we can solve today's impossible problems, what will we ask of the supercomputers of tomorrow?